Welcome back, everybody. Moving on to the next question. Write a polynomial inequality that is never true and show why. Now, this is a communication type of question, and whenever they're talking about polynomial inequalities either being always true or never true, you're usually going to see x to the power of even numbers. So like x squared, x to the 4, x to the 6, x to the 8, etc., etc. And the reason why is because these expressions will always be greater than or equal to 0. You're basically guaranteed to have that. Because if you throw in a negative x value into any of these, it'll turn positive. And then if you put in 0, then it will be 0. And if you put in a positive number, it will be positive. So basically, these expressions can never be negative. So an example of a polynomial inequality that is never true, well, something simple like x squared plus 2, for example, is less than 0. Notice how this can never be true, because x squared always has to be greater than or equal to 0, right? And then this plus 2 makes this whole expression always positive, meaning it can never be less than 0. And you can also see this graphically. So x squared is just a regular parabola like that. Well, x squared plus 2 means we take this parabola and shift it up by 2 units. So this is x squared plus 2. And notice x squared plus 2 can never be less than 0. The y values are never negative. So this is an example of a polynomial inequality that is never true. And you can also add in other variables that have even exponents. So we don't just have to have an x squared. We can have maybe x squared plus x to the 4 plus x to the 6 plus 3. And this we can say is less than 0, which is never true. Because this is always going to be greater than or equal to 0. This will always be greater than or equal to 0. This will be greater than or equal to 0. Then this plus 3 always guarantees this left side to be positive, meaning it can never be less than 0. I don't know how to graph this right now, this polynomial function on the left side, but we can just tell algebraically, because of these even exponents, that this expression on the left side is never less than 0. So this is another example of an inequality that is never true. Right? So different ways to show it, algebraically, graphically, and just an infinite amount of choices to answer this question.